Let's do question 5. So here we have h comma k equals 2 comma 0 and the point x comma y equals 4 comma 4. So first I'm going to write the vertex form of the quadratic function, that is f of x equals a times of x minus h quantity square plus k. Now first I'm going to plug in h comma k, that is for h I'm going to plug in 2 and for k I'm going to plug in 0. So therefore this becomes f of x equals a times of x minus 2 quantity square plus k is 0, so it becomes 0. So this is basically the quadratic function. However, we have to determine the value of a, which is a constant. And for that, I'm going to plug in the point x comma y equals 4. So here I plug in x equal to 4 and y is basically f of x. So I'm going to plug in f of x equals 4. So therefore this becomes 4 equals a times of 4 minus 2 quantity square, and this is 0. So let's determine the value of a from this. We get 4 equals a times of 4 minus 2 is 2 and 2 square is 4. So we get the equation 4 equals 4a, and this implies we can determine the value of a by dividing both sides by 1. So we get 4 by 4 equals 1. So we found the value of a equals 1, and that means we can write down the quadratic function by plugging it here. So therefore we say that this is the vertex form. F of x equals a is 1 times of x minus 2 quantity square. Now this is the vertex form of the quadratic function. We have to write down its general form. So for that, I'm going to expand the right side. This is basically a binomial, which is x minus 2 times x minus 2. And when we fold this out, we get x squared. This is negative 2x. This is one more negative 2x. And this is the negative 2. Negative 2 is positive 4. So we get x squared minus 4x plus 4. So this is the quadratic function f of x equals x squared minus 4x plus 4 in general form. Let's do question 47. So here we have h comma k equals 0 comma 1 and x comma y, that is the point, is given as 2 comma 5. Once again, we will first use the vertex form of the quadratic function, that is f of x equals a times of x minus h quantity square plus k. So first let's plug in h comma k, that is 0 comma 1 into f of x. So replace h by 0, therefore it becomes x minus 0 quantity square, and replace k by 1. So we put plus 1. Let's simplify this. So this equals f of x equals a times of x squared plus 1. We have to determine the value of a. For that, we use this point 2 comma 5. So we replace x by 2 and y is given as 5. So this basically f of x. So replace f of x by 5. So therefore this becomes 5 equals a times of x is replaced as 2. It becomes 2 squared plus 1. So we get 5 equals 2 square is 4, and 4 times of a is 4a plus 1, and this implies we can now solve for 4a. This is by subtracting 1 from both sides. When you do that, we get 5 minus 1 is 4. Now dividing both sides by 4, we get the value of a equals 1. So we have determined the value of a, and that means we can plug it into the quadratic function, which is in the vertex form. Therefore f of x, and this equals a is 1, that is 1 times of x squared plus 1. Let's get this simplified. So this is f of x equals 1 times of x squared is x squared and plus 1. And this in fact is already in general form. We will not have to rewrite by doing some other methods. So this is the general form of the quadratic function. Let's do question 49. Here we have h comma k equals negative 5 comma 3 and the point is given as 2 comma 9. So first let me write the quadratic function in vertex form. So f of x equals a times of x minus h quantity square plus k. So once again we put the h comma k into this. So therefore this becomes f of x equals a times of x minus h is negative 3. So it becomes negative of negative 5. This I can write down as positive 5. So I'm going to put x plus 5. This is quantity square plus k is 3. So I put 3 here. Now we have to determine the value of a. For this, let's utilize the point 2 comma a. I'm sorry, it is 2 comma 9. So I'm going to replace f of x by y, which is 9, and x by 2. Okay, so a times of 2 plus 5 quantity square plus 3, and so this becomes 9 equals a times of 2 plus 5 is 7, and 7 square is 49. So it becomes a times of 49 plus 3. Now let's find the value of a. First I subtract 3 from both sides, so I get 6 equals 49a, and this implies if we solve for a by dividing both sides by 49, we get 6 by 49. So this is the value of a which we have found, and so we can plug it into the quadratic function which is in vertex form. Therefore we have f of x, this equals a times of, that is 6 by 49 times x plus 5 quantity square plus 3. Okay, so this one is in vertex form, but we have to give it in general form. So first, let's expand this binomial. That is f of x equals 6 by 49 x plus 5 quantity square, and this equals x plus 5 times x plus 5. So we can FOIL this. X times x is x squared. With 5 it is 5x. Now 5 times x is 5x, and 5 times 5 is 25. So we get 5x plus 5x is 10x. This is x squared plus 10x plus 25. So let me put this here. This is x squared plus 10x plus 25 plus 3. Let's distribute the terms of 6 by 49 into the terms inside the bracket. So therefore we say that f of x, and this equals 6 by 49 x squared, and 6 by 49 times 10, we just have to multiply the numerators 6 and 10. It is 60 over 49 x plus this is basically 25 over 1. So we multiply 6 with 25, which is 150 over 49. Then we have this plus 3, so I put this 3. So we can combine this fraction because these two are numbers. So therefore we see that f of x, and this equals 6 by 49 x squared plus 60 over 49x plus let's simplify this. I put 150 over 49 plus, since we have to simplify using the common denominator, which is 49, and multiply this 3 with 49 and divide by 49. And so this equals 150 over 49 plus 3 times of 49 is 147 over 49. We now add these two numbers in the numerator because we have the common denominator 49. So 150 plus 147 is 297, and this is over 49. So I put this constant or the number 297 over 49. And if you look at this function, this is the standard form of the quadratic function. That is f of x equals 6 by 49 x squared plus 60 by 49 x plus 297 by 49.